Hi, this is Ron Stites again. I'm going to go over how you interpret the significance, p-value some people call it, but in SPSS it's the significance for various tests that we do, including the test for normal distribution, the t-test comparing two groups of means, and ANOVA, which compares more than two groups of means. Here we have a test for normality. And what you see is the significance is very low. Notice here's a histogram, and you can see this is not normally distributed. So the normal test assumes the null hypothesis is that a normal distribution and the distribution we're looking at are the same. And this says that these data do not support this at all, certainly not at the 0.05 cutoff limit that we have. So we reject the null hypothesis that this distribution is equal to the normal distribution. Anytime it is below 0.05, we would say, nope, this is not right. Now here's some other tests, charts that we'll just go past that, and we'll not work on those. This is the t-test, has some similarities. We're comparing two groups to see if they have the same mean. The null hypothesis is that these means are indeed the same. Well, when we look at them real closely, we see that the means are really quite a little bit different. And then when we do the t-test and look at the significance, it's zeros, or at least very low, well below the 0.05 cutoff limit we have. So the null hypothesis is these means are the same. These data do not support that. In fact, the probability of these being the same is much lower than our 0.05 cutoff limit. So we conclude that these means are not the same, they are different. When we go to ANOVA, we are comparing more than two means. ANOVA null hypothesis would be that all the means are identical. Notice that it says no, that's a very low probability. There's a very low probability that they are the same, well below our 0.05 cutoff limit. So something in there is different. But since there's more than two, we don't really know which ones are different and which ones are the same. That's why we do the post hoc test, in this case a Duncan test, and it goes and does a bunch more calculations to see which means are actually grouping together. And we can see that two of them group together, and then the rest of them are actually independent. They are different from each other. So the first test says something is different. The second test, the post hoc test, tells us which things are different and how they line up.